day, ma'am. My name is Nelson C. Reyes. My report is all about network segmentation and switches. Relieving network congestion with a combination of powerful workstation, audio and video on the desktop, and network-intensive application. 10 Mbps Ethernet network no longer offer enough bandwidth to fulfill the business requirement of the typical large business. As more and more users are connected to the network, an Ethernet network performance begin to lag as users fight for more bandwidth. Ethernet division. One way to solve congestion problems and increase the network performance of a LAN is to divide a single Ethernet segment into multiple network segments. Increasing a single segment to multiple segments maximize available bandwidth. Some of the techniques that can be used to create multiple segments are as follows. Physical segmentation. The network can be segmented with bridge and router thereby breaking up the collision domains. Breaking up the collision domains minimize packet collision by decreasing the number of workstations on the same physical segment. Network switching technology or microsegmenting. Like a bridge or router, switches can also provide LAN segmentation capabilities. LAN switches provide dedicated point-to-point packet switch connection between their ports. Since this provides simultaneous switching of packet between the ports in the switch, it increases the amount of bandwidth open to each workstation. Full duplex Ethernet device. Full duplex Ethernet device can provide almost twice the bandwidth of traditional Ethernet networks. For this work, the network interface card must be able to run in full duplex mode. A switch is a full duplex device. Fast Ethernet. Using fast Ethernet switches can provide 10 times the amount of bandwidth available from 10 base T. FDDI. FDDI is an older solid technology that can provide 10 Mbps bandwidth by running dual rings. It has the capability of running up to 200 Mbps. FDDI is typically used between closet, in floors, or in campus environment. Segmentation with a bridge. A bridge can segment or break up a network into smaller or more manageable pieces. However, if a bridge is incorrectly placed in the network, it can do more harm than good. Bridge perform their work at the MAC sublayer of the data link layer. Bridge create both physical and logic separate network segment to reduce traffic load. There are solid advantages to bridging. By segmenting a logic network into multiple physical pieces, network reliability, availability, scalability, and manageability are ensured. Bridge work by examining the MAC or hardware address in each frame and forwarding the frame to other physical segment, but only if necessary. Bridge build a forwarding table of information composed of each MAC address and which segment that address is located on. Segmentation with a router. Router work at the network layer and are used to route packet to destination network. Routers like bridge use table to make routing decision. However, router keep information only on how to get to remote network in their tables. Not to host router use this information to route packet through an internetwork. Routers use IP address instead of a hardware address when making router decision. The router keeps a routing table for each protocol on the network. The benefits of using router to segment are manageability. Multiple routing protocols give the network manager creating an internetwork a lot of flexibility. Increased functionality. Routers can address the issues of flow, error, and congestion control, plus fragmentation, reassembly, and control over packet lifetime. Multiple active paths. Using the port addresses called Destination Service Access Protocol, Source Service Access Protocol, and path metric router can make informed routing decision. as well as interpret the next layer protocol. Routers can have more than one active link between devices, which is a definite plus. Segmentation with LAN switches. LAN switching is a great strategy for LAN segmentation. LAN switches improve performance by employing packet switching that permit high-speed data exchanges. Just like a bridges, switches use the destination MAC address in order to ensure that the packet is forwarded to the right outgoing port. Cut-through switches begin forwarding the packet before reception is complete, thus keeping latency to a minimum. One architecture. In any one internetwork scenario, one of the main building blocks is the router. The main function of the router is a forward IP packet, which we also refer to as a datagram, from the source to the destination across the network. This operation of forwarding these various size packet can indeed become a very complex operation. The routing of this packet depends mainly on the size and overall configuration of the network. Routers can perform additional tasks, such as filter the flow of packet between different nodes in the network. Protocol architecture. In general network layer, routing can be divided into two basic functions, control and forwarding. The forwarding component is responsible for the actual forwarding of packet from the input device to the output device across a router or a switch. In order to forward a packet, the sending device uses two sources of information. The router maintains a forwarding table and the information contained in the packet itself. The control component is responsible for the construction and maintenance of the forwarding table. Each router in the network will implement control and forwarding components. The actual network layer routing is performed as a composition of control and forwarding components implemented in a distributed fashion by a set of routing that make up a network.